All right, so 2.6 is all about logarithmic functions. So this first video is going to be about what is a logarithm. It's kind of a fancy word, and a lot of people do not use it very often. So a logarithm is a function, just like an exponential function, just like a quadratic function. It's a type of function. So as we go through math, what we find out is that everything has its inverse. So adding has the inverse of subtraction. Multiplying has the inverse of division. Having something squared, so if you square something, the inverse of this is the square root. If you have something cubed, the inverse of it is the cube root. So every time you have an inverse, what it does is it undoes things. So for instance, if I had x plus 1 equals 6, if I use the inverse and I subtract 1, what it does is it undoes the problem so that I end up with being able to solve for x. If I have the square root of x squared, those undo each other, so that undoes that, so all I have left is x. The cube root of x cubed, those undo each other, so all I have left is x. Well, when we're dealing with exponential functions, when I have the function, the exponential function 2 raised to the x power, we have to have some way to undo it, because now the base is the number and the variable is the exponent. So how do we undo these things? Well, we use logarithms. So exponential functions and logarithms are inverse operations. A logarithm is just another way to write an exponent. So it's just a different setup, if you will. So on your Canvas page, I do have a PowerPoint that goes through all the different properties of logs and all of that, but I am going to go over it here. So a logarithm is just an exponent rearranged. Okay, that's all it is. It's just an exponent rearranged. So let me give you an example. If I have 2 to the third power equals 8, that's an exponent. It's 2 raised to the third power equals the total of 8. Well, a log is just an exponent. So I have a base of 2, so that is going to be in the sub. It's a subscript, so it's a base of 2. My total is 8, and my exponent is 3. So if you notice, I'm using the exact same information. I've just rearranged it. So when you read a log, you're going to read it as 2 raised to the third power gives me 8. So let me do this in color code so you can see where all the values are set up. So if I have 5 to the second power equals 25, that's an exponent form. Okay, so I'm going to change colors on this. So 5 raised to the second power equals 25. So watch how I write this. Log base 5 subscript of 25 is going to equal the exponent 2. Okay, so now look at the colors. If you notice, my base is 5, that goes here. My total is 25, that goes here. And my exponent of 2 goes here. So this is where we come up with the idea of a log equals an exponent. It's just an exponential function rearranged. That's all it is. So what you're going to do in your My Math Lab is they're going to give you either an exponential function and you have to write it as a log, or they're going to give you a log and you have to write it as an exponential function. So let me just give you a couple examples of each kind so that you can see how it works. So if I start with an exponential function and I want you to write it as a log, okay? So log, L-O-G, is just the shortened version of logarithm. So exponential function changed to a log. So I have 7 raised to the second power equals 49. So in My Math Lab, they're going to give you something like this. You have to change it into a log. So log base 7, so it's in the subscript, it's in the basement, of the total equals the exponent. Okay, log base 7 of 49 equals my exponent. Log base 7 of 49 equals 2. Okay, let's try another one. So we're going from exponent to log. 3 raised to the third power is 27. So I want to change that. So log base 3, so it's this 3, of 27 equals my exponent. So again, a log is an exponent. A log is the exponent. A log is the exponent. Let's do one more. 9 raised to the second power is 81. So log of base 9, so log base 9 of 81 equals the exponent 2. Okay? So now you have to remember your exponent rules. So if I continued with this, if I had 2 raised to the negative third, that equals 1 over 8th. Okay, so log base 2 of the total equals my exponent. Log base 2 of 1/8 equals negative 3. If you had 5 raised to the negative 2, that would be 1 over 25. So remember, a negative exponent says just flip it over. So 2 cubed is 8, flipped over is 1/8. 5 squared is 25, flipped over is 1 over 25. So written as a log, it would be log base 5 of 1/25 equals negative 2. Okay? All right, so that's going from an exponent to log. If you're going from a log to an exponent, again, all it is a rearrangement. So log base 5 of 125 equals 3. So it's given to you as a log. Now we're going to go log to exponent. Okay, so this is my base. This is my exponent. This is my total. Okay, let's try another one. Log base 8 of 64 equals 2. So 8 is my base. 2 is my exponent. The total is 64. So log base 8 of 64 is 2 is the same as 8 to the second power equals 64. So going from exponent to log and log to exponent, it's just a rearrangement of the information is all it is. So if I have log base, well, I'm going to do it this way. Log base 7 of 243 equals 3. Now I got to double check my numbers. Hang on. I think it's 7 to the third power. 7 to the third power. Oh, 343. Sorry. I knew that was close. Okay, so log base 7 of 343 equals 3. As an exponent, it's 7 raised to the third power is going to give me 343. All right, so that's what a log is. When you're working on your calculators, it's just log, or if you see in your My Math Lab where there's no base, so let's say I have log of 100. All right, when there's no base, this is the same as base 10. So that's called a common log. So when you have base 10, it's not going to show it. It's an assumed 10, okay? So if this is log base 10 of 100, so when you simplify this, what this is asking, whenever you see the term log, this is saying, what's the exponent? So it's going to be, what's the exponent on 10 that gives me 100? The exponent on 10 that gives me 100, which is 2. Now, if you use your calculator, and you're using base 10 only, that's the only way to use your calculator at this point. So on your calculator, you'll have a log key, L-O-G. All you have to do is hit log 100 equals or enters, and it's 2. So that's what that's saying. 10 raised to the second power gives me 100. Okay? How about this one? Log of 10,000. So what's the exponent on 10 that gives me 10,000? Okay, which is 4, because 10 to the fourth power gives me 10,000. So what this does, what a log does, is it allows me to be able to solve using the common log, base 10, quite easily. Okay? All right, so that's what a log is. It's just an exponential rearrangement. Okay, so there's log base 10, which is your common log. And then there's also one that's called a natural logarithm, or natural log. So the natural log is always used on the natural number e. So if I'm going from an exponential function, so e raised to the second power is 7.389, and I just use that on my calculator. If I want you to change it from an exponent to the natural log is ln. So on your calculator, you do have an ln key. That is the natural log. That is base e. Okay, so natural log and base e are special inverse operations. So if I were to rearrange this, I would say the natural log of 7.389 is going to equal 2. So natural log is base e. I'm not going to show it, right? So because e and natural log just automatically go together. So e is your natural number, ln is the natural log. Those are inverse operations.